today on the Diabetes Podcast.
Development is entrenched in epigenetics, turning one fertilized egg into a whole body that's full of specialized tissues is largely the story of the right pages opening in the right cells at the right time. The hypothesis is if the wound environment is unusual, like there's a higher glucose signal, could it influence which pages get marked as the baby building itself? Could it leave notes in the margins that persist after birth?
Hello and welcome to the Diabetes Podcast. I'm Richie.
And I'm Amber.
And Amber, little administrative note to start out today. If you are just now listening to the podcast, you are new, or whether you've been listening for a while, and you have prediabetes or type 2 diabetes, and would like to know what you can start doing right now to make this better, we've put together what we call the Remission Roadmap, and that is available for download for free if you go to thediabetespodcast.com. You can download that Remission Roadmap as well as sign up for our newsletter so you're getting updated when the new episodes of the podcast drop. Again, that is at thediabetespodcast.com.
All right. Awesome.
And without further ado, we are going to get into part 3 of our 4-part series on reproductive health and diabetes.
Mm-hmm. Exactly. And this is more about what the baby remembers.
Okay.
But it's not memory like in the way that we would think memory. It's more like the genetic memory,
Okay.
if you will. Yeah. So I'm going to do a quick recap because we've laid the groundwork in episode 1 and 2 about how pregnancy deliberately creates insulin resistance and what happens.
Every pregnancy creates insulin resistance. I think that was kind of the big
Didn't I
eye-opening.
say every? Why pregnancy?
I don't know if you said pregnancy, but to me, the real takeaway was that the increased
Yes, we're not just talking about
insulin
gestational
resistance
diabetes. Yeah,
is a part of all pregnancies. That's a normal
Yes.
thing that happens.
That's exactly right. And we've also talked about what happens when there's not enough insulin to overcome the resistance. The glucose can be too high, and the baby's pancreas can produce extra insulin there. And we followed that same insulin story in episode 2 backward into polycystic ovarian syndrome, which is now in 2026. And I did not discuss this on the last episode because I didn't know it because it's new this year. But I love this change. They now call it polyendocrine metabolic ovarian syndrome. And that's the updated official medical term for it. And the reason they updated that name is
because there's no cysts involved.
Yeah, we talked about that in the episode. There's no cysts there. And it really has to do with this very complex hormonal and metabolic disorder, which is really like the whole point, like how timely that I saw this change in what was PCOS to PMOS, because it just goes right along with everything that we're talking about, why the name changed. And it was also believed that term, thinking it was cysts, the polycystic, and they aren't cysts, it was thought to have driven delayed diagnosis, and the name obscured the severe metabolic and multi-system defects defects either way of the condition. So it's just recognizing that multiple hormone systems are involved and not just reproductive hormones. And then it really highlights that condition's link to insulin resistance, weight issues, and future potential risk of developing type 2 diabetes.
But it also speaks to, again, we're very diabetes focused, obviously, on this podcast, but that metabolic health umbrella is really, really broad. Like there's a lot of stuff Like, never have I ever even thought prior to the last episode that ovary function was influenced by insulin levels or insulin resistance. That to me, it's a new thing that I learned last week.
Yay. So today we're going to follow the story forward across the placenta in with the baby and then potentially into the rest of that child's life. And so we really want to map this out honestly because there's 3 kinds of very different claims in this topic, and I don't want to throw them together the way that headlines might. And as we talk about this, it'll make more sense about those 3 different claims and ways you can look at this. But what we know is very solid physiology. So there's that, and there's human studies that are consistently associated with diabetes in pregnancy. And then there's what's still an evolving hypothesis, which is where the realm of epigenetics really lives. And if we treat that hypothesis like it's a proven fact, that's where women can get frightened for no reason. And then if I dismiss a real association just because there isn't absolute proof, then I hide something that might actually matter to someone's family who's experiencing gestational diabetes or PMOS. So I'm going to walk that line carefully. And today I really want to highlight when the ground might get a little soft under our feet, when the evidence is not so black and white, as oftentimes it's not. So when epigenetics is really a great example of how it's not, and we'll talk about that. So let's get established physiology out of the way, and I'm going to do it kind of quickly because we did talk about that in episode 1 and episode 2 quite a lot. And the whole thing in brief is that glucose crosses the placenta. Maternal insulin, for the most part, does not. And when more glucose reaches the baby can't borrow the mom's insulin to handle that extra glucose. The baby's own little pancreas has to make its own. And because insulin isn't just a blood sugar hormone, but a growth hormone, a baby making extra insulin gets an extra growth signal, which can mean a larger baby. It can mean a dip in the baby's blood sugar in the hours after birth. And that's why those babies might get heel sticks to test their blood sugar. And it's not a surprise because the nursery is anticipating that this could happen in the baby. And so like that part is solid, evidence-based. We know what's going on with the physiology of mom and baby and after birth and all of that. And treating gestational diabetes, we know measurably improves the outcomes for the baby and mother. So large randomized trials, very clear on that. So I'm not going to go into that more because we talked about that in the gestational diabetes episode. So I'm telling you all that quickly on purpose because I want to spend some real time on something a little bit harder. I want to spend it on the question of what happens after all that is over, after the birth, after the blood sugar sticks with the baby, when the mother is at home at 2 a.m. and wondering if this pregnancy left a lasting mark on her baby, on her child. So how could a pregnancy possibly reach years into a child's life? So I'm going to start with an idea that a developing baby is not in the womb with this very fixed genetic blueprint. It's not like A plus B equals C plus D equals E. It's not this, and that is that. It's this developing and evolving state where the baby is responding to the inputs from the environment within the placenta. So it's just constantly listening to the nutrients, the hormone, the oxygen, and those signals across the placenta. So the baby is thinking, not literally thinking, but as it's developing, am I developing in a world of plenty or in a world of scarcity? What are the stream of signals coming in from the mother that is a source of intelligence for the baby? And it's almost as if It's silly to say this, but I think of like a baby and they're placing bets, like what's it going to look like? How's it going to be? It says like based on everything that I'm sensing, this is probably the kind of world that I'm being born into. So let me tune into the frequency for that world. And this is a really divine feature. I don't know if divine is the right word, but it's a really magnificent feature, not a flaw at all. This is a really magnificent, elegant thing that happens in how humans and probably many other living beings in the world as well. And it's that flexibility that is exactly why our species can thrive in the desert or in Arctic conditions and everywhere in between, because the baby is supposed to listen and adapt, and that's by design. And there's a whole field that deals with this. So I am by no means an expert in this. I don't claim to be. In fact, I claim the opposite. This is outside of my lane as a dietitian, diabetes educator. But this is called DOHaD, which is Developmental Origins of Health and Disease. And the core idea is just this, that development is responsive. And so the real question is the same question that we tend to ask in every episode, is what happens when, well, every episode in this reproductive section is what happens when the baby is calibrating to the unusual. What happens when the glucose signal that it's reading is higher than what was expected to be the reading? And to answer that, we're going to dive into the world of epigenetics. And that's why there was this preface in the beginning about epigenetics, that we're really talking about a dimmer switch. And the science on this is phenomenal and also very nuanced. So, and it's also a very fancy word that when you hear it, you're like, ooh, that whoever's talking about that must be smarter than me. So listen up, everyone. Not really. So I'm going to try to explain epigenetics, not being a geneticist, but being someone who's really fascinated in the world where epigenetics plays a role in nutrition. The first time that I remember was a professor I had in college who did a lot of research on homocysteine levels, and they did this work with certain rats, and they were like these golden mice. And anyway, it was really fascinating stuff. And it really traced back to the grandmother, like several generations where epigenetics could come into play. And they've even seen that in some human studies where in rats it was probably like the great grandmother. I don't know, because rats don't live as long, but in humans there's some really interesting studies that show the way that the grandmother ate and the environment of the grandmother played a role in the baby. And when you think about it, the baby's eggs are in the grandmother's body at one point, because the mother is born with all the eggs that she has for a lifetime. So did I make that? A female is born with all of her eggs for a lifetime. So the grandmother is carrying the baby that has all of her eggs for a lifetime. And that's how it goes to the grandmother in the epigenetic lineage. So it's so cool. And nearly every cell in your body carries the same DNA, the same complete set of instructions. Your liver cell has the same set of instructions as your muscle cells, your pancreatic beta cells. They all have this same manual, and yet they behave completely differently. How? Not because they have different manuals, because they read different pages. So imagine that your DNA is that Joy of Cooking cookbook, and it's got every single recipe that you might want to make. Well, almost. It's a pretty thick book, but not everything. But in the genetics, it absolutely does have every recipe you might ever want to make. And it's not that epigenetics rewrites the recipes. It just may only make the recipes that are vegetarian, or only make the recipes that don't have nuts in them. Like it's very specific on the pages that it's always going to be open to, the pages that have the corners dog-eared, and maybe it doesn't look at all at the pages that are all stuck together by some sweet something that you made, and those pages aren't going to open. So it really depends on which pages are open, and the way that the body marks those pages is through a few molecular mechanisms, chemical tags that are placed directly on the DNA called methylation, adjustments to the proteins the DNA is spooled around called histones, and these little regulatory RNA molecules that fine-tune how loudly a gene is expressed. You don't need to memorize those. So just really hold that picture, that physical marks in the margins that turn the genes up and turn that dimmer switch up and down without ever changing the words. Now, here's why this matters for our story. It's because the womb and development in the womb is really entrenched and drenched in epigenetics, that you have this one cell that turns into multiple cells that specializes into organs. And so many of these things get turned on or turned off at different points in development. And so the hypothesis is, if the wound environment is unusual, like there's a higher glucose signal, could it influence which pages get marked as the baby building itself? Could it leave notes in the margins that persist after birth? And the answers that researchers give is plausibly yes, maybe yes. We've found epigenetic differences in the placentas, in cord blood, and I say we, I was not doing this research, scientists have found this, and in the children of pregnancies affected by gestational diabetes. And that's real, and that makes epigenetics a believable bridge between the pregnancy and the baby's later biology. But, and this is the whole reason that I insisted on the beginning piece talking about hypotheses versus absolute solid research and the nuances in between. Plausible does not mean proven. And where this gets shaky is also where the science can get overstated very easily. And most of the human epigenetic studies that have looked at this were very small, and they looked at different tissues, different ages. They didn't always find the same marks. And there's a deeper problem with the epigenetic differences in that usually you can't tell whether it's a cause from altered metabolism or a consequence of it, or just a marker running alongside something else entirely. And on top of that, tissue matters enormously. A methylation pattern you could measure in cord blood doesn't automatically tell you what's happening in that child's pancreas or liver or muscle, and those would be tissues that are very metabolically active that you would want to study and look at. And a lot of the cleanest mechanistic work comes from animal studies, where researchers can control the exposure and examine any tissues that they want.
That's kind of what I was thinking as you're describing this, is that it would be very, let's just say, ethically challenging to put together a robust experiment on developing children for life. I mean, like, you know what I'm saying? Like, the only way to replicate the experiments that they're doing in mice is to kind of mess with some levers as a child is actively developing, and it just is probably never going to, we're probably never going to be able to replicate that level or that kind of experiment in humans.
Well, I mean, and the lifespan of humans versus the lifespan of rats. Like you,
well,
how many,
like even just
how many rat
even just what you were
lifespans do you
talking
have?
about, like you could take a tissue sample from a developing rat fetus or something like that, and as opposed to very targeted tissue sampling in humans is always going to have some risk of harm to the developing fetus. So you're just not going to be able to do that.
So many things. And they even have like knockout mice and knockout rats. I mean, where they knock out entire sets of genes that do a particular thing and then see what that looks like.
Again, not going to be able to do that.
Yeah, for sure. Yeah, and so the big thing is also a mouse is not a person, and a mouse's development is not a person's development. So the epigenetic processes are real and absolutely central to normal development. Maternal diabetes is associated with measured epigenetic differences. It is a biologically plausible piece of developmental programming, but we do not have a single epigenetic signature that predicts any individual child's future, and no single high glucose reading is going to flip a switch that doomed you for life there, and is just a word that describes biological responsiveness, not the fate that you're going to have for the rest of your life.
I think it's probably safe to say that the environment, and we've talked about this before, particularly I think on the episode with Dr. Nadler, the environment can shape or affect gene expression. And I think it's also safe to say that ability of the environment to shape gene expression is not just in adults, but over the entire life spectrum, up to and including that gestational period in the womb.
Mm-hmm. Mm-hmm. So if epigenetics is the plausible mechanism, what do we actually see in children over time? Because a mechanism is only interesting if there's a pattern that you can explain through the mechanism. And there is a pattern because studies repeatedly find that children whose mothers had gestational diabetes carry on average a somewhat higher risk of things like excess body fat, future risk of type 2 diabetes, reduced insulin sensitivity. And so I guess one of the biggest examples of that was from the HAPO study, which is hyperglycemia and adverse pregnancy outcome, where researchers assess the children of mothers with gestational diabetes at around age 10 to 14. And among those whose mothers had met the criteria for gestational diabetes, 10.6% of them had impaired glucose tolerance as compared to only 5% of those whose mothers did not have gestational diabetes. So you have twice the risk there among those whose mothers had gestational diabetes.
But still relatively low from a portion of the total population, by which I'm getting, it's very easy to say if you had gestational diabetes, your child's risk of being metabolically impaired is twice what normal is, but that's still only a tenth of that population. I'm not saying it doesn't matter, but again, I think it's further reinforcing that your child's not doomed. There's plenty, or there's a high likelihood that they'll be just fine.
For sure. Yes. I see exactly what you're saying. Yes. And by that same token, to be age 10 to 14 and have some signs at that young of an age is still concerning. But I think it's concerning with the population as a whole in younger adolescents, for sure. And that we talked about that in the environmental podcast because it's changing and this study is meaningful evidence. And to your point, I don't want to wave that away, but exactly what you're saying, it's associated. It's not, it's observational evidence, which is where they can tell you that two things travel together, but they don't tell you which one's steering the boat, if you will. So the trap can be that while you notice that these children have higher risk and you ask why, there could be three different answers that you could come up with by observing that study. You could say maybe it's the womb environment, the programming? And that's an interesting answer. Maybe it's genes. The child inherited the same metabolic tendencies that gave the mother the gestational diabetes in the first place. Or maybe it's the shared home, same food traditions, the same sleep and activity patterns that shape the mother's metabolism. And those things are just wound so tightly that even the most sophisticated even the most sophisticated statistics can't unwind the interconnectedness of all of those things, because you can just never perfectly measure any single one thing of those very shared influences. So we have to refuse two opposite mistakes. The first mistake is shrugging and saying it's just an association, so the pregnancy doesn't matter. That's going to ignore the physiology, the dose response patterns, the animal work, and some clever human studies that we'll talk about in just a bit. And the second mistake is declaring her glucose programmed the child to get diabetes, because that claims far more than we can prove for any individual kid. And so the truthful position lives somewhere in between. The pregnancy environment appears to contribute to later risk. It's not the only contributor, and it doesn't seal the outcomes or the fate. It's
probably not the main contributor to
right.
Yeah.
So now the clever human evidence is that researchers found one elegant way to separate genes from the womb, and that is to study siblings. Same mother, same genes, often the same household. But what if one sibling was born before the mother developed gestational diabetes and another was born after? And then those kids had two different womb environments while sharing nearly everything else. Studies in Pima families did exactly this, where they looked at siblings born after the mother's diabetes, gestational diabetes developed, and had a higher risk of obesity and type 2 diabetes than the siblings born before. And that's a real point in favor of a very genuine interuterine effect. It's clever, but it's still not airtight. The two pregnancies happened years apart. The mother was older. I think about you and your youngest sibling, 16 years apart. Me and my youngest sibling, almost 13 years apart. And I don't think that these studies had siblings that far apart, maybe 4, 5, 6 years from what I remember, but still drastically different. I think about my mother's income level with me versus income level nearly 13 years later with my sister, and even things like food security in that environment. Yeah. So the point is, the sibling studies shrink those confounding variables, but they don't eliminate them. So the most reasonable takeaway from all of this is very unclimactic. It's not really cool. And it's that the womb probably matters, and genes do matter, and the environment after birth also matters. And the thing about biology is it almost never makes us pick just one. There's so many factors at play in human biology. And here's a twist that might be surprising, but it's one of the reasons why scientists take this whole field of developmental programming seriously. And it's because a lot of the foundational observations made in this area did not come from too much glucose at all. It came from the opposite direction, from famine and studies on people who were going through famine. And they found associations with later differences in glucose metabolism and heart and metabolic health. And out of that came this idea called the Thrifty phenotype. And it's also been called the predictive adaptive response. And so remember that baby in the womb calibrating for what it's expecting. So if you can imagine a baby sensing scarcity, and it tunes the dials to be exquisitely thrifty and will hoard every calorie and store food aggressively because it's betting on a hungry world, which is brilliant if the world is hungry. But if that child is then born into abundance, the thrifty calibration and the actual environment are mismatched. And that mismatch may set the stage for metabolic trouble. And it's really too neat to say too little and too much. The outcomes are the same where there's a mismatch, or that famine does this, but it's just not that clean because famine doesn't exist in a vacuum. There's also stress, illness, disrupted healthcare, disrupted care in general, a lot of times trauma, and that it also doesn't take into the consideration that different points in the pregnancy respond differently to inputs or the environmental things that are going on. So I'm not going to just say there's this rule around it and that's that. But I would like to notice what the scarcity story and the high glucose story have in common, and why that convergence between the two is so striking. And it's two completely opposite environments, but they point at the same underlying principle that development responds to context. The body is constantly adjusting to the conditions it meets, and an adjustment that fit the womb can turn out to fit the outside world quite poorly. And that's far more accurate and more living in the realm of humanity and humanness to picture that than imagining this passive baby waiting to be handed a fate. And so I'll pull this whole scientific arc together in one sentence, because this is really what I would like the mother to carry home. And it's that pregnancy is an influential chapter in this incredible book of life, of a child's life. And even where a real programming effect does indeed exist, it's a tendency and not a destiny. It's a nudge on the dial and not turn the lock and throw away the key. And we know this precisely because of all of the research that's done on what happens after birth. And the genome doesn't get rewritten at delivery, but the body keeps responding to the inputs, to breast milk or formula, to the first foods that are introduced, to sleep, to movement, to growth spurts, to puberty, to the whole social and food environment that the child has grown up in. And a prenatal influence can generally be meaningful without being the final word, which also means I won't sell you the opposite idea that a parent can erase every inherited or prenatal risk through flawless choices after birth. It's just overreach wearing some kind of a mask of hope. Parents influence health.
I got an analogy.
Yeah, give it.
Let me know if it's
you're
a
good at
one or
these.
not.
Let's go.
Okay, so as you're describing this environment, both before and after birth, I'm reminded of, we watched the Chernobyl series on TV.
Yeah.
Not a very happy story. A lot of mistakes were made. But at one point, like, they'd done the math to figure out that they could expose you to this level of radiation for like 90 seconds. So they had just rotating crews that were cleaning up this roof in 6-man teams, and they'd go out for 90 and they'd come back in front. And that was the maximum exposure that you could have to an incredibly high level of radiation with a reasonable amount of risk. As we're talking about metabolic health, as we're talking about elevated insulin levels and elevated glucose levels and all that kind of stuff, I think it's safe to say if we can limit the duration of the exposure, period, that's a good thing. If we can limit the intensity of that exposure, that's a good thing as well. But particularly the duration is really, I think, more germane to what we're talking about today. The environment that your child has in the womb is really the only time in that child's life where you control 100% of the inputs for that kid. As soon as that he or she's out, you lose 100% control of the dietary inputs on a long enough timeline. You lose all influence. That kid's going to start feeding themselves and going out and doing all that kind of stuff. So it's not to say that, like you said, before birth's going to affect this person's entire life. It all matters. Every phase of the child's life has the capacity to improve metabolic health or diminish metabolic health. But this is one window in which you, as a loving parent, can completely affect all of the inputs for that 9-month gestational window. So not to say, like you said, you're never going to get it right, but it's probably prudent to do your best to limit both the intensity and the duration of any kind of high or elevated blood sugars or insulin, high levels of insulin surrounding that.
Yeah. I don't know why this just came in my head because it doesn't feel completely relevant, but it feels relevant. And that's that once someone quits smoking, after 20 years' time, they're on the same risk level as someone who never smoked. And it's funny because the little me that sometimes can be devious or maybe not my best self, I don't know. And I'm in there like, that's not fair. I never smoked. But I think it just speaks to the resilience of the human body. And just because something happened at one point that wasn't so great doesn't mean that you're doomed forever. Like never quit, never throw in the towel was the idea behind this, is that you do your best with the circumstances that you have. You control the controllables, and all is never lost, but also it still matters right in the here and now. I don't know. That's what I was thinking, but.
Well, okay. So how about this? If you're currently pregnant, it's valuable to be aware that your current state of metabolic health will affect your child.
Absolutely.
And that you can, throughout pregnancy, affect your metabolic health. There are things that you can do to make that better.
And our gestational diabetes episode tells how and why.
Those
without doom and gloom.
For those, this episode is occurring more as an after the fact. If you had gestational diabetes, okay, there's still a lot of things that you can do right now that will still continue to influence your child's metabolic outcome. So it's not to say forget about it, it's not a big deal, but that the effort to create that environment, that healthy bubble around your kid as much as you can, there's still a lot of work to be done. It doesn't all happen during that 9-month period.
Yeah, I mean, managing glucose during pregnancy demonstrably reduces the risks that we understand the best. And the American Diabetes Association's 2026 Standards of Care put common pregnancy targets in place for a reason, because those were the targets found to best mitigate the risks associated with gestational diabetes. And that was a fasting glucose under 95, a 1 hour post meal under 140, and a 2 hour post meal under 120. Now, of course, your own physician might have different goals for you, and this does not supersede the goals that you and your physician have worked out and talked about, especially if you are a female with type 1 diabetes in pregnancy, or you have frequent hypoglycemia. Things could look different with your goals. But those numbers are information, not grades, pass or fail. There's no moral connection to that at all. It just is something to try to stay within to minimize risk. plain and simple. And there are also numbers to help determine whether insulin needs to be given in the first place or increased or decreased. And the reason that insulin is given during pregnancy is it is considered quite safe during pregnancy is because it's one of the drugs that does not really cross the placental barrier. And a big thing also is that the physiology changes throughout the course of pregnancy. The insulin resistance that's on purpose increases with the increase in pregnancy hormones. And so the breakfast that you had at month 6 during pregnancy could look completely different from the breakfast you had at month 7 or 8 during your pregnancy, based on where the hormones are or how much insulin you needed at that time, whether you injected it or your body was producing it, whether it can keep up for the demand if you need more of it. It is just what it is. Like, it's what's needed to control the blood sugars, to keep the blood sugar across the baby has access to within those normal levels. So that's the goal. And you cannot out-discipline the placenta. Like, those hormones are insane. I've seen many pregnant women with gestational diabetes on a 1-to-4 insulin to carb ratio, which means for every 4 grams of carbs, you have a unit of insulin. Wow. So if you had a normal 40-gram carb meal, you've got 10 units of insulin for that, which is a lot for people who are used to like 3 units of insulin for that same meal. So it really can double or even triple the needs for insulin during pregnancy. And if your body can't keep up with that really high demand, then you would need to inject it exogenously. So that's during gestational diabetes. But if your pregnancy is already behind you, like your child is 2, 12, 22, maybe not 22, maybe it's a little too old, like 2 to 12, somewhere in there. This is where shaped and not sealed becomes quite practical, because you have gestational diabetes, which is one risk factor, not a diagnosis for your child, but a risk factor. And because so much of metabolic health keeps developing after birth, the years since are full of chances to influence which way that story plays out and how it goes. So the most useful response to that is not to put your child under a microscope and not to put them under this surveillance at every meal, where it's like, you eat that, you're going to get diabetes, like I had diabetes. And that really doesn't serve a purpose other than to create fear, anxiety, shame, all of those things around food, which is the absolute opposite of what you're trying to do. And I often will say to people who ask me, like, just tell me what to eat. Like, what's a good thing to eat on a diabetic diet? And the answer to that is, what's a good thing to eat, period. And because what's good for the goose is good for the gander. And it's always interesting that I've heard people tell me in the past, so I make my meal and then I make the meal for the family, because the family's going to just revolt if you put the food that you're having to eat in front of them. And it's just fascinating to me, because I guess with our kids, and I know I have a completely different experience with the profession that I chose and what I did, but with our kids, this is the meal that is prepared in front of you. This is the meal for the family. You can eat it or not. And if you're hungry enough, you'll eat it. And we'll get into, this is a lot more about what the next episode is about. So like just a little preface and a primer for that is more like what happens with the risk to mother from a mother who's had gestational diabetes. What does that risk look like throughout the years? And so if you had gestational diabetes, you want to have an oral glucose tolerance at different points. You want to have it at 4 weeks postpartum, 12 weeks postpartum, and then screening every 1 to 2 years for life. Just make sure you have that screening. And then just really briefly, I want to touch on breastfeeding, which we'll talk about more the next episode. But the main thing is that you nourish the baby in the best way that you can, whether that is breast milk or formula. Hard stop. Just making sure the baby is well nourished, and you follow the directions, and you seek out your pediatrician, or if you have the benefit of a WIC dietitian, the program for women, infants, and children, whose funding has been cut. Anyway, that's a great resource to talk about early childhood nutrition. So yeah, that's the long and short of it. So I think that the message to the woman who monitored every single carb and every single thing that they ate or drank at every meal and still delivered a large baby, or a baby who needed some sort of glucose support after birth, that care that was given to every meal, to all of that, did reduce risk. It does make a difference, but it never guarantees an outcome. And the main reason for that is that ultrasound estimates have limits. Genetics affect size, placentas vary, the baby's own biology and physiology can vary, and the birth outcome is not your moral failing or shortcoming or anything like that. And by the same token, the baby could have high glucose and have no problems whatsoever that you can outwardly see. It's just the thing about health science, is because we want this really clean, because I did this, then this happened. And that's just almost never is what happens or the truth. So I do believe we introed this as what the baby remembers. And I think we think of memory as like this very conscious thing. And in this aspect, or in this respect, that's not what we're talking about. We're not talking about a meal or a fasting number that the mother had, not a moment where the mom saw the blood sugar number too high on the meter and was just filled with some emotion around that. The baby reads signals crossing an extraordinarily busy placenta. Its own pancreas answers, its tissues grow and specialize, and gene activity gets dialed up and down as it builds a body that is suited for the world that it's sensing. And some of these adaptations might echo after birth, and that is very genuine and worth understanding. But no biological memory acts alone. After birth, a flood of new signals arises. Milk, the first foods, sleep, comfort, movement, illness, relationships, puberty, the whole wide environment, and biology keeps right on responding. And that is exactly why a prenatal influence can matter but not be that fate or destiny, because the body remembers signals, but it also never stops responding to new ones. So that's the thing, is that I just want to have the mother who had gestational diabetes, or who does have gestational diabetes, to understand that do as much as you can to mitigate risk, but also understand that not any single one thing is going to claim that baby's entire future. You want to mitigate risk to have a healthy pregnancy, to have a healthy baby, to have a live birth of that baby. But
to reduce your own long-term risk for diabetes.
Yes, absolutely. But I think there's enough scary stuff out there that we don't have to harp on that stuff. It's just do as much as you can, get the best education that you can, ask questions of your healthcare providers, do the best that you can to help mitigate risk. And that doesn't necessarily seal the fate of your child once the baby's born. There's a lot of things you can do after birth to have a very healthy child and a very healthy life. So I really like that because I often think, what if I was breastfed longer? Or I was breastfed quite a bit, but or like women who struggle with breastfeeding, like, what if I'd have been able to do this? Would I have been able to decrease their risk? And it's just, you just do the best you can with what you have always. And we'll talk about that more on the next episode as well.
Okay. Well, this has been another episode of the Diabetes Podcast. Thanks for listening to the Diabetes Podcast. Be sure to tune in next week when we wrap up our 4-part series on diabetes and reproductive health. If you like what you heard, please click that follow or subscribe button, and don't forget to check out thediabetiespodcast.com for that free pre-diabetes and type 2 diabetes remission roadmap. Until next time, take courage. You can do this, and we can help.